Hi everyone, welcome to Winpoint online classes. Today we are going to discuss one of the important topic from the chapter electric charges and fields. This topic is very important because we are going to discuss a law here, Coulomb's law. So objectives of this session is to learn about Coulomb's law. Now we have a clear idea about charges. There are different types of charges, positive and negative charges, and different types of interaction, attraction and repulsion. These things now we are very familiar. In the last videos we have been discussing about this. Now we are going to discuss Coulomb's law. Let us start the discussion. Coulomb's law. Coulomb's law is dealing with force. If you are considering two charges, it can be positive charges, it can be negative charges. If you are taking any of the two charges, there will be interactive force between the charges. It will act in a straight line direction. Okay. For that we are considering two charges, charge number 1 and charge number 2. There are two charges here, and one is Q1 and other is Q2. So it is Q1 and it is Q2. The distance between these two charges, it is R. So there is a distance between these two charges, it is R. This we are considering here. Now we have discussed there will be interactive force because these are electrostatic charges. So there will be interactive force. It can be attractive force or it can be repulsive force. What is the unit of charge? The unit of charge is coulomb. This we have discussed in the last video, and you have learned the unit coulomb in the class 10th also. Here we are considering two charges. What is going to happen if we are increasing the charges? When we are increasing the charges, what is going to happen? Like we are taking 10 coulomb and 10 coulomb, two charges 10 coulomb, and there are another two charges 100 coulomb. Which force will be stronger? 100 coulomb or 10 coulomb? Yes, it will be 100 coulomb because the charge is more. If we are increasing the amount of charge, the force of attraction or repulsion will be more. So how we can increase the force of interaction? Increase the magnitude of the charge. If we are increasing the magnitude of the charge, the force will be more. So one of the factor which is affecting the interactive force is magnitude of the charge. The magnitude of both charge. If we are increasing Q1, there will be increase in force of interaction. If you are increasing Q2, there will be increase in force of interaction. If you are increasing both charges, there will be increase in force of interaction. So this force of interaction depends on both charges. So we need to consider two charges together. Okay, force is proportional to the magnitude of the charges. The force of interaction between the charges will increase with increasing magnitude of the charges. This is the first factor which is affecting the force. Now let us discuss the second factor. Here you can see two pairs of charges. Here Q1 and Q2, and here also there are two charges Q1 and Q2. What is the difference between these two pairs? Yes, in this pair the distance is very less. The charges are close to each other. What about this pair? In this pair the distance, it is far away from each other, right? The charges are far away from each other. According to you, in which case there will be more interactive force? First one or second one? More interactive force. Here charges are very close to each other. Here charges are far away from each other. Which pair is going to experience, which charge is going to experience more force? Yes, if the charges are very close to each other, there will be more force. That is the second factor. Distance between the charges. If the distance between the charges it is more, then force will be less. If the distance between the charges is less, that is if they are very close to each other, then force will be strong. Just imagine you have two magnets. You are keeping the magnet very close to each other. The attractive force will be more, right? If we are keeping the magnet far away from each other, there will be less attractive force. The same thing, if we are keeping the charges close together, attractive force will be more. If the charges are far away from each other, the attractive force will be less. So the next factor which is depends on the force of interaction is distance. Experimentally it is found that it depends on the square of the distance. So we can say that force of interaction is inversely proportional to the distance. If the distance is more, force will be less. That is inversely proportional. Let us write it. The force of interaction between the charges will decrease with increase in distance between the charges. These are the two factors which are depends on the force of interaction. There is one more factor, medium, that we will discuss. Okay. Coulomb's law states that the force of interaction between two charges is directly proportional to the product of the charges and inversely proportional to the square of distance between them. Product of the charge means magnitude of the charge. We need to consider two charges. So we are taking product of the charges. You need to learn this law. Force of attraction between or force of repulsion between. Generally we can say that force of interaction between two charges is directly proportional to product of the charges and inversely proportional to square of distance between them. It's a very easy rule. Now let us write the mathematical expression. Coulomb's law. We are considering two charges. We are going to write the mathematical expression. Okay, equation we are going to find it. Q1, Q2. There are two charges Q1 and Q2. Distance is R. According to Coulomb's law, force is proportional to product of the charges and force is inversely proportional to square of distance between the charges. Two factor only. Okay. First we are writing F. Proportionality sign is proportional to. We need to use a sign. This is the proportionality sign. F proportional to product of the charges. First charge is Q1, second charge is Q2. So it will be Q1, Q2. That is the first mathematical relation. F proportional to Q1, Q2. Then second one, it is inversely proportional to. Force is inversely proportional to square of distance between them. How we will represent inversely proportional to? There is no specific symbol for that. We are using the same symbol as we have used in the previous equation, previous mathematical relation. Instead of this Q1, Q2, here it is inversely proportional. So we need to use 1 by R square. Okay. If it is directly proportional, just R square, but it is inversely proportional. So it will be 1 by R square. So here we can write F proportional to 1 by R square. That is the reason for this reciprocal. It is inversely proportional. R square has to be at the denominator. Okay. Now here, when we are observing these two mathematical relation, you can see that the force F is common here. In both mathematical relation, F is common. So we are taking that F outside. We are taking that F as a general factor. F proportional to. What is the other factor? RHS. If we are taking LHS as common, we can write RHS also as single term. Right? It will be Q1, Q2 into 1 by R square. Both term we are taking. It will be Q1, Q2 by R square. Okay. We can write it together. Now we are going to make equation. Equation means there has to be an equal. Here we have only proportionality sign. We need to change that proportionality sign into equal. What is the method? Yes, add a constant. Here we are adding a constant here. Then the proportionality sign will be equal. So it will be, we are replacing the proportionality sign with a constant. F equal to, here the constant is 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0. Epsilon is permittivity. We will discuss it later. Now after this discussion we are going to discuss this permittivity. Okay, 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is the equation for force according to Coulomb's law. You need to learn this equation. F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Okay, you have to learn this. Q is charge, R is distance between the charge, epsilon 0 it is permittivity of free space. We are going to discuss this permittivity now. Permittivity. Okay, permittivity is a topic which you are going to learn in higher classes, but you need to have a clear idea about permittivity because we have that in our syllabus. We are using that permittivity term in Coulomb's law, so we are going to give an idea about this permittivity. For example, we are considering two charges, charge number 1, charge number 2. It is Q1 and it is Q2. Okay, Q1 is interacting with Q2. Similarly, Q2 is interacting with Q1. These are charges. There will be force of interaction. So this Q1 is passing some of the energy, electric energy. Q1 is transmitting some of the electric energy for interacting with Q2. If there is an interaction, the charge has to transmit some electrical energy. So this Q1 is transmitting some electrical energy to interact with this Q2. So it is transmitting through this medium. Here in between the charge there is a medium. Okay, so electrical energy is passing through this medium. When electrical energy is passing through this medium, some of the energy the medium will absorb. Just imagine charge Q1 is transmitting 100% of energy. That 100% is not going to reach here. Maybe 60% of the energy the medium will absorb, only 40% will reach here. That is called permittivity. It is the ability of a medium to store electric energy. Every medium is having this ability of a medium to store electric energy. That is called permittivity. Okay, we are considering permittivity of free space. That value we need to learn. Okay, so if you are considering permittivity, the equation will be F equal to 1 by 4 pi epsilon Q1 Q2 by R square in general. If we are considering permittivity of vacuum, then it will be epsilon 0. Now it is epsilon only. You can see that because it is general equation. When we are considering permittivity of vacuum, it will be epsilon 0. Permittivity of vacuum, the value of epsilon 0 you need to learn 8.85 into 10 raised to minus 12 farad per meter. Now what will be the equation? F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. That is the equation for force according to Coulomb's law. Okay, you need to learn this equation. That's all for today. In the next class we are going to discuss vector form of Coulomb's law. That is also very important topic. Thanks for watching.